practical topic. Hall effect invented by Edwin Hall, 1879, Class BSc2 Group Cap. What is Hall effect? The Hall effect is the production of a voltage difference, the Hall voltage, across an electrical conductor, transverse to an electric current in the conductor, and to an applied magnetic field perpendicular to the current. It was discovered by Edwin Hall in 1879. For clarity, the original effect is sometimes called the ordinary Hall effect to distinguish it from other Hall effects which have different physical mechanisms. The Hall coefficient is defined as the ratio of the induced electric field to the product of the current density and the applied magnetic field. It is a characteristic of the material from which the conductor is made, since its value depends on the type, number, and properties of the charge carriers that constitute the current. Apparatus required. Hall effect setup consists of semiconductor crystal slabs, 0.3 mm thickness, mounted on wooden frame with 4 contacts on it, Gauss meter electromagnet constant current source, connecting wires.
Hello friends, first of all, we are performing a Hall effect experiment. We know all about application apparatus separately. This is all big circuit that measures current and voltage across an extended semiconductor. Constant power supply by constant current source for pair, the flow of wire to the pair of electromagnetic and magnetic field maintained between them, and this sensor measures magnetic field and it's connected to the digital Gauss meter, where the magnetic field displays digital Gauss meter. This Gauss meter along with sensor which will be used to measure the magnetic field between the 2 points of electromagnet. 4. Hall probe. The Hall probe is a sensor used to measure the strength of a magnetic field. First of all, insert eccentric semiconductor between the pair of electromagnets and adjust the current of constant power supply 0.5 ampere by rotating the knob. And set Hall voltage to 1 microvolt by adjust a knob, and note down the corresponding Hall current by selecting microampere on Hall effect setup. Similarly, set Hall voltage to microvolt and take down the corresponding Hall current and repeated the same procedure to take the more readings.
Current is applied to the constant current from where it flows to the wire to the pair of electromagnets. Magnetic field is maintained different. This sensor measures the magnetic field and is connected to the Gauss meter, where the magnetic field is displayed. Varies current in constant current generator such that the magnetic field between the poles of the electromagnet becomes 2000 Gauss as the state of the cosmic gas.
Combination of formula. Let us consider a piece of semiconductor of length ion mixed with a current flowing through it as shown in figure. If V be the transverse magnetic field applied to the crystal, then the charge in the crystal experience the force vector along perpendicular direction to both X and V. Due to this force, the electrons gather near the upper surface of the crystal, making it negative with respect to lower surface. Such separation of charges induces an electrical potential called Hall voltage Y, and hence corresponding electrical field A. The force experienced by electrons due to Hall electric field is theta, which is in opposite direction to that of BEV, and hence it prevent further deflection of charges. RH equal to 1 by NE equal to BYD by IXB is called Hall coefficient. That is 1 by RH equal to N is charge carrier per unit volt. This is an observation tab will come out through the reading of Hall current and Hall voltage. Current and voltage. This is an complete experiment of Hall effect. Thank you.